hello, hello, hello. I'm late. I'm late for a very important, not date. It's a quote from somewhere though, I forget. I played a game that had that exact quote. I'm late for a very important date. But here I am. Let me just get set up and all that. Alright, here we go. Boom. It's me. Wow. And then let's get started. Took long enough. Vertical screen, let's go. So this is what we're gonna be doing. We're gonna be trying to wrap up the lip sync stuff. So right now, it's just the, just recording stuff. Had a user on Discord point out that I don't have to use the audio effect record thingy. I could just use, well, there's another thing I can use, which is audio effect capture. And I think audio effect capture just runs continuously as opposed to running in chunks. So basically just another thread to run. I guess it'll work, I don't know. I guess it'll work. So here's what we're gonna do. Here's what we're gonna do. Let's go to audio. I wonder if I can just add an audio effect capture. Oh, yeah, there we go. We can just have it here, so I don't even need to, like, on ready, create it. Yeah, so let's see. We don't want record. Is this stuff, actually I haven't checked. Is this stuff already pushed? Open C face. Yeah, it's close enough to being pushed. We'll call it a good enough. Let's see. So record, we'll delete the effects, add the capture effect, then I'll reorder this just so I don't have to do anything else because I'm lazy. And then this will be an audio effect capture now. So audio effect capture. It will still be called record, but that's okay. Right, then record, set recording active. That's going to change as well. AEC. So now this is going to break a bunch of stuff. Audio effect capture. That's okay. Let's see. So this. Oh, interesting. So this is just almost like an entirely different way of doing stuff. Maybe. Okay, that's interesting. That's interesting. Okay. Interesting. Let's follow this and see where it goes. Let's follow this and see where it goes. Yeah, so they're doing this entirely via code, which I actually prefer, by the way. Okay. So delete everything. Let's just do this all via code. Get rid of this default layout. Alright, so this does not work at all now because I have intentionally broken it. So let's look at this reference code now. So there is no more record bus. Now we just have the bus, I guess. Yeah, so we don't need to play anything, right? We just need to capture audio. So yeah, I guess this is good enough then, probably. We'll need a bus index, so this will just be this will be audio server get bus count. Ooh, this is not a thing, get bus count? Have I been lied to? I have a feeling that this is not. Oh, it's just the bus counts. So then they're using the explicit getter as opposed to the property. Okay, that's okay. I dislike using the getter. So audio server, add bus index. Oop. Set bus mute, it'll be the same index. And then bus effect, we're gonna add the capture effect. Okay, hold on. So audio server, set bus mute, bus index, true. Yeah, that makes sense. Then AEC will be equal to audio effect capture. Really struggling not to do this syntax. I've been writing a bunch of Rust recently. Ugh. Which is why I'm late. I'm very tired as well. So this is AES. We'll call this AES, right? AES. So there's the audio effect capture and the AES spectrum. So audio effect spectrum analyzer instance, I guess. And I think that these are roughly the same thing, if I remember correctly. So we load up this. This is an audio effect, and then this is also an audio. This is an audio effect instance. Maybe I should have done this just via. All right, hold on. I don't remember if this is something that you can do. Get bus effect instance. Yeah. Set bus mute. Then we'll do audio server. Add bus effect. Bus index, right? Audio effect, so this will be for sure AEC. And then the position we don't care about. Yeah. Okay. Does that mean I'm gonna need one of these? Like var AES effect will be equal to audio effect spectrum analyzer. Because this is just a regular audio effect, right? Yeah, and then I can get the audio effect instance from that. So this will be like audio server, add bus effect, bus index, AES effect, and then this will need to be. Oh, that is bizarre, right? Like the order of operations here, I'm not a huge fan of that. Audio server. Get audio, get bus effect, instance. Yeah, this is the same thing, right? What I could do is something like this. So we'll just add them in this step, and then we'll just grab it later as well. Something like that, right? Yeah, okay. So this works. Just so it's like a consistent methodology for adding bus effects. So this is AES. So we need the bus effect instance in this case, not the actual bus effect. Yeah. Now, this one, we don't want to start and stop the recording constantly, so this needs to be AEC. Well, we need to still do buffer management. So what is the? I'm familiar with audio effect capture or audio effect capture. So there's clear buffer, get buffer, buffer length. Yeah. Length of the internal ring buffer in seconds. Setting the buffer length will have no effect if already initialized. Get buffer or get frames available. What's the difference between get buffer length frames and get frames available? So get buffer length frames returns a total size of the internal ring buffer in frames, and then get frames available returns the number of frames available to read using get buffer. Yeah. Ooh. Wait. So returns get buffer length frames returns the total size of the internal ring buffer in frames. But get frames available returns the number of frames available to read using get buffer. Something doesn't seem right here. I don't know. Give me one sec. I need to look at the Godot stuff. What does the Godot implementation say it does? I'm a little nervous. Luckily, Godot is one of those things where if you're not sure of how something works, you can just look at it. If I know where does audio effect capture just kind of stored? This is in the audio server. Does this mean that there's an audio effect that I can just look at as well? So that's audio effects. Okay. So let's see if we can figure something out. Audio effect capture. So there's the header, and then we can look at the implementation to start. All right, let's look at the header first, just in case. So it has a ring buffer, push frames. Yeah. It's a friend class. Gross. Public audio effect capture has a default constructor, I guess. I'm not super familiar with this syntax. But I'm going to assume that just means like default constructor. So set buffer length, get buffer length. I'm looking for get buffer length frames. Wait. Where is it? This is get buffer length frames and then get frames available. This is get frames available and then get buffer length frames. What is the difference between these two methods? So this is get buffer length frames. This is buffer size. Okay. And then this is data left. Okay. What's the difference? Where does the buffer come from? How big is the buffer? So the buffer is ring buffer. Where does ring buffer come from? Ring buffer is in core header. So this is in core. Like, what's the difference between buffer? That's what I'm confused about. Is what is buffer? What's the difference between buffer size and data left? That sounds like the same thing to me, but maybe I'm crazy. Ring buffer, ring buffer, ring buffer. Is it not here? Ring buffer. Yeah, header only. Okay. Advanced read. I'm looking at data left and buffer size. This is space left. Data left, which is size space left. -1. Sure. And then size. Size is just size. What? Oh, it's just like the size of the ring buffer in its entirety. Okay. Interesting. Interesting, interesting. But data left is the size minus... Wait. Ooh. Wait. Hold on. Get frames available is more specific as opposed to size. Wait. Frames available is more specific than get buffer length frames. Yes. It's weird. Yeah. So buffer length. No, get frames available. Get frames available is more specific. Because get frames available calls data left. Data left calls get buffer length frames internally, or I guess externally to go up in abstraction. Size is equivalent to get buffer length frames. Yeah. Get buffer length frames is called by get frames available. Get frames available calls this method. No, this method. Yes. What am I talking about? So this is the size of the vector, sure. Then space left is space left ever called just by itself? No. Okay. Space left. So left is the read position minus the write position, and then if left is, oh, this does some ring buffer shenanigans. Okay. Okay, cool. So I think what I'm gonna do is just use this. Excellent plan, me. Good job. So this is going to be... So I guess I no longer need to store like an internal counter for the buffer. Then now I can just do this. So it'll be audio effect capture gets buffer length frames. So we just check to see if this is greater than or equal to 5. No longer use buffer like at all. So say goodbye buffer. Yeah, because now we can just directly check the buffer. Get magnitude, etc. This is going to be... It won't be an audio stream sample anymore, but I think that's okay. Oh no. Wait a minute. Audio effect capture. So this might break now. Now that I'm looking at it more, I'm starting to lose confidence once again. Because at least with audio effect record, you could define like a sample rate. This might just have a sample rate of 8 bits. Whereas this one just gives me audio frames, right? Oh, this is a pool vector 2 array. What? Hold on. This is a pool vector 2 array? Ooh. Hold on. That's weird. So this is what's their ring buffer then? Their ring buffer is a vector of type T. Sure. What? So what is this? This is an audio frame. Okay, ring buffer of an audio frame. The audio frame is in core math audio frame. All right, so let's take a look. Core math audio frame dot header. Oh geez. Oh no. Is audio frame used by audio effects record? Oh no. Not like this. Audio effects record. This uses okay, so it uses the same ring buffer at least. Okay. Getting nervous. This implementation looks very complicated. Now I don't have a reference anymore. Now I need to do actual math by myself. All right. So I don't need to look at the ring buffer implementation anymore. That's fine. But we don't have an audio stream sample anymore. So now I think what I need to do here is just kind of cheese it, as they say. So we'll look at what audio effect record is doing. So once you know, I call get recording here. What does it do with its audio frames? Let's see, set recording active. Where's get recording? Okay. So these are all uints 8s. Okay. Forcing mono is not implemented. That's good. This is an audio frame. Oh jeez. What the heck is this? And it wasn't audio. Audio frame also had a accompanying C++. Okay, never mind. Nothing in it. It's a header only file essentially. So there's the left sample and the right sample. Okay. So let's get this done really quickly then, because I'm gonna need to do a little more hands-on conversion. It looks like. So this does some conversion for me automatically that I cannot depend on anymore. But here, what we're doing is if our audio effect capture get buffer length frames is greater than or equal to 5, we're only ever going to use just 5 samples. Because that's how the implementation works. We only work on 5 frames at a time. So that should be okay? Question mark. Right, this is still breaking. Okay. So frames available. Well, this is going to be a pool vector 2 array. So this is audio frames. AEC dot get buffer. And then we'll just hard code it to 5. So I think we do still need this constant, right? Buffer. So we're always working off just this set buffer length of 5. Gotta love it. So this goes away. Max value. Hey. What are they doing here? This doesn't do anything. Okay. So playback, we don't need to do anything. Yeah, because that's the audio stream generator, I guess. Audio stream. Oh, I think I still need the audio stream player as well. Yeah. So audio ASP, so audio stream player. We'll create this as well. So audio stream player is equal to audio stream player new. So ASP dot the bus that it's actually working off of needs to be, or am I able to set the bus? How do I set the bus? Or maybe not. Maybe I don't need to do this for audio stuff. That's fine. We'll see if it doesn't work, and then we can just add it to our main screen if necessary. Am I able to rename the bus? Now I'm thinking about it. Am I able to rename this bus? So add bus. And what do I have in addition to this? So I can set the bus. Oh yeah, I can set the bus name. Yeah. Okay, so let's do that. Add bus. Audio server. Add bus. Or set bus name, I guess. So bus index. Just bus name. Easy. Still have it just be record. That's okay. So if we need to add an audio effect or audio stream player later, then we can actually connect it to a specific bus. So that'll be all right. Let's see here. We have our audio frames. I don't know what I'm going to do after this. Read 16-bit samples needs to be converted somehow. Let's see. If this is true, so if we are using lip sync, okay, then we want to check all of this. And then if, I guess we don't need to do this final else statement. That doesn't matter. And then we don't do any buffer stuff either. So now we can just convert it to this. And then we can do the standard if not whatever, right? Because this is a very specific type of function. Boom. So we can also de-nest our if statements. Early return if necessary. Wait. This needs to be doing the volume like this. How does wait, frequency range, what does this work off of? This works off of I have no idea. I have no idea what this works off of. Audio effect spectrum analyzer. Buffer length 5. Okay, so I do need to customize the buffer length. Yes. So AESA is equal to this thing. SA buffer length, I guess, will be equal to buffer, and then that should be okay. Can I not do this? Oh, right. Var. Sorry. AESA. So then that should be all right, probably. What was the value it was defaulting to? Oh, it was defaulting to like just 2. That's tiny. How about FFT size? So it defaults to an FFT size of 1024. I don't know. What's a tap back position? What the heck is a tap back position? There's so much like audio stuff I don't know about, and that I also like have very little interest in. Audio effect spectrum analyzer. Sure, there's your enum. Yeah, gotta love a good enum. What's a tap back position? Ooh, tap back position. Still don't know what this means. Tap back position. Where is this used? Tap back position. Yeah. But like, what is this used for? What the heck is a tap back position? This isn't used in any methods here. There's an instance. I can see that there's a audio effect spectrum analyzer instance. Sure, but there's no instance here unless this is like an inner class. Yeah, there is an inner class of this. But that class isn't implemented though. Ooh. What is the tap back position? It doesn't look like it's used. That's weird, man. That's weird. I have no idea. I guess we won't worry about it too much. Alright, but this is going to be, if it's less than this, then we'll just return early. Well, I suppose we should clear, right? So we'll do audio effect capture clear buffer. Then we'll do all of this stuff later. So either way, we're going to be clearing the buffer, right? Either way, we're always going to be clearing the buffer. Or I suppose we can just do it like this. This is fine. Just so we only need to clear it once. So AEC, clear buffer. Now this part is going to be tough. This part is going to be tough. So get recording. So this is for audio effect record, not for audio effect capture. But I need to know what they're doing here. So this is an audio effect record. This is the header file. Is it? Yeah, this is audio effect record. Yeah. That's fine. This is audio effect capture. Is there a difference between audio effect capture instance? Audio effect capture. Oh, well, I guess I'm not able to create an audio effect capture instance. Bizarre. So you can create an audio effect spectrum analyzer instance, but you can only use the audio effect capture audio effect by itself. Huh? Who wrote this, man? Alright, well, either way, this is what we got. You know what? I think I do need to do this. I need to resize it. Alright, so AEC, we're just gonna do it like this. Audio effect, capture, new. AEC. We won't need to do this part. Yeah, it's gonna be a little messy. It's always gonna be a little messy. That's 100% sure. It's just the nature of the beast. So audio effect capture, right? And then audio effect capture buffer length, we'll set it equal to 5, I guess. That should just be doable. And then for recording, I need to implement whatever they're doing in C++ in GD script. Oh baby, this will be fun. So we can make it static as well, why not? So this is to sample. So this takes a pool vector2 array, which will give me it's not really an audio stream sample, but it's close enough. What is stream data? What is this? Audio stream sample. Data is pool byte array. So this should return a pool byte array as well. But it'll be in the format that's being expected by this function here. Oh, hello, core activities. Sup? Did you go to the University of Georgia? Is this why you say dog? Like so? How are you doing on this fine evening? It's actually very cold for me, but I'm German, it's cultural appropriation. Unacceptable. I'll let you go on this one instance. If only because I'm just completely mind-flooded by what I now need to do. It's okay. I'm pretty sure the University of Georgia culturally appropriated spelling dog like D-A-W-G. Anyways. That's a university where I went, though. So I suppose you need some way of writing dog that's not D-O-G. Otherwise, it's kind of weird. Especially when I think the university saying when I was there at least was dogs on top. I was like, I don't know. Starting to get kind of weird now. Do you use updog? Yeah, sometimes. Have you heard of Dragon, though? And what I'm working on is, I'm working on lip sync stuff. So I do technically have lip sync working. Dragging these nuts over your forehead. You thought you could get me with the original Ligma, or I guess Updog. But as it turns out, I got you instead. You gotta try a lot harder than that to get me. But yeah, I have lip sync working for these types of models. And by these types of models, I mean this model. I probably actually don't have the license to use this model, but I do technically have a license to use this model. Hello. You win this time. Well, you know, that's why they call me Team You Win. He's too good. Someone stop this man. Too weeaboo for me? Well, I apologize. You know, weebs have the most expendable income, you know? Like they don't even like, you know, like sports fans, yeah, they got a lot of expendable income, but they also spend that in like meat space. But weebs, you know, you're not gonna. What, are you gonna go to like an anime concert? I don't think so. You're just gonna buy merch. And so all this is doing right now, this is doing like actual face tracking and mouth tracking, but it's not doing any real-time lip sync right now because this is the current release build. But what I need to do is I'm changing my implementation from using an audio effect record, which is really only supposed to be run like once every like 30 seconds or whatever. And I'm changing it to use an audio effect capture, which instead uses a ring buffer. But the data format it gives me back is different. Duxbury, you want that sweet pillow money? Hey, you know how much like a body pillow costs? Like I bought a body pillow as a gag gift because guess what? I don't have an anime body pillow, but I did know because I wasn't sure what to get my little brother for his birthday, so I was like, all right, yeah, here's an. You know, it'd be funny. Get him an anime body pillow, and let me tell you, that stuff cost me like $20, $120 USD. This is just ridiculous. It was stupid. Recording data. Current instance, recording data. I need some sort of continuous byte stream, I guess. Yeah. I do have a continuous byte stream. Like, this is the problem though, right? So you can see here on my second monitor, right? This is what I need to use. This uses a ring buffer. Somewhere. This uses a ring buffer somewhere. Whereas this is what I was using previously, which is audio effect record, but I need to use an audio effect capture. Why are they different? I don't really know. I don't really know what the difference is. I don't know why they're different, but they are. And so you can see here that to get the recording, which just gives me back a vector of U8s, it does all of this complex logic, whereas this one, all it does is it just gives me the vector directly. A real one for that? Yeah, you probably could. I'm not really in the business of paying for, you know, a little bit of hanky panky. It's much better when it's free. Oh, actually, scrub that from the log. That sounded really rapey. I didn't say it. What I meant was you could just talk. You could just talk to them. Just convince them that you are man enough to do the deed. Actually, that still sounds like really rapey. I'm just gonna stop talking. just gonna stop talking. There's no good way to talk about that. Ugh. What am I supposed to do here, by the way? So we can resize this. That's okay. Results, resize. We're doing it. I need this in 16-bit format. What is recording data? I think you should visualize what you get from that function. Oh, absolutely not. Like, this is what I get. This is what I'm working with, is an audio frame. Right? And then this is what I'm kind of basing my implementation off of. So we're just getting the buffer, and then we're clearing it immediately. So what we're going to do is to sample here. So we'll hit it with a little bit of to sample. Hold on. To sample. Look at that. And then audio frames get sent. Yeah, so I know what I get, and I know my old implementation works. It also has a tendency to crash after about 5 minutes. It's not my fault. So here we are. What is get buffer? Clear buffer, get buffer. Oh, actually, hold on. This is what this gives me. Get buffer, data left, pull vector 2 array. So this resizes it. And I think this is just the data directly. So this is what I'm getting. This is what I want it to give me. Okay. So let's figure this out. Resize. We'll resize it to just size 5, I suppose. And unfortunately, I'm the kind of person that revels in dirty jokes. I apologize. So, despite being an actual adult, you know, I just kind of have the joke mentality of like a 5th grader. How unfortunate. So what is this? What is this? We're looking for current instance. So that should be an audio effect instance. Recording data. Audio effect instance. Where does this come from? Audio. This is an audio effect capture. No, audio effect record header. This must be defined here. Recording data. Yeah, recording data. Where is it? Recording data. So this is a wait. What? What? Wait a minute. This doesn't make sense. Doesn't this use a ring buffer? Ring buffer. Yeah. Yeah. What? So I thought it was also using the same ring buffer, but I guess it doesn't. Ooh. Because I can't just push everything into the same thing. Let's see. So in the process thingy, okay, so they have an audio frame. They have a pointer to a ring buffer. Audio frame, sure. Oop. This part. What the heck is this? Source I? Ooh. Pointer. Source frames. Ooh. All right, there's your ring buffer, sure. Give me this. Ring buffer, ring buffer, ring buffer. So this is only in the audio effect record, it looks like. Where is this used? Ring buffer is only ever used in the audio effect record instance, whereas audio effect capture uses... Yeah, what I need to figure out is how audio effect record is converting ring buffer data into recording data. Because this is what I get. I get the recording data, but it looks like it's storing the audio frames instead of a ring buffer. Audio effect capture just gives me the ring buffer as a pool vector 2 array. It's annoying. So when you instance it, it creates the ring buffer stuff. Sure, sure, sure. Okay. Let's continue to just stare at that and hope it makes sense to me at some point. When does the... So current instance... Alright, bring me back to the header. God, I hate it when the header files... That's something that I still can't get over for for C++ is the fact that like it's nice that you're able to, you know, split up like the interface essentially and the actual implementation. But it's annoying that I just don't know what variables are there if I'm just looking at the code. I can't just scroll up. So current instance. Eh? Where was it? Current instance. Where's current instance stored? Yeah, okay. So it's just a reference to current instance. Current instance is an audio effect instance. Okay. Cool. Actually, let's keep that open. So current instance, recording data. Eh? When does that get changed into recording data? Eh? Set recording active. Get recording. Recording data. When does recording data get set? That's what I need to know. Recording data. Init. Push back. IO store buffer. Buffered frame is from the ring buffer. Oh, I see. Okay. That is so strange. Do you see this? Look, this. Who wrote this? Why would you make this? Why would you make it like this? Why would you make us like this? So what they're doing is, I don't know when IO store buffer is called. Maybe I can find out. Update buff. Okay, so when do they call update buffer? Update buffer is called in one of these functions. Updates. I don't know. Update buffer. IO thread process. Thread callback. I guess they just started? Yeah. But anyways, once they call IO store buffer, then they get a pointer to their ring buffer, I guess? Oh yeah, they do some pointer arithmetic with their audio frame, I suppose. And then their ring buffer, which contains vector 2s, which means it's 2 floats. What is this? So this is like the ring buffer read position and the ring buffer mask. I don't really understand what that's doing. Actually, yeah. What bitwise operations also confuse me. So let's see. Godot bitwise operators. What are the bitwise operators for Discrete? Get me out of here. Discrete basics. Bitwise operators. Bitwise operators. Bitwise operators. So it's bitwise and that still doesn't really help me, but sure. So that's the ring buffer read position, which I don't have access to. I suppose it doesn't matter though, huh? Because I can assume that they'll just be ordered. At least in the GDScript code. Yeah, I think that this stuff is just ordered. Yeah, and then we'll just send it. Yeah. So the data comes to me as a pool vector 2 array. So then we'll do for data in data. We'll do results push back I dot x. Right. So we're just emulating what we're emulating what this is doing here, right? So what is your problem? At read 16-bit samples, call argument 1, pull byte array does not match the expected argument type. Okay, so which means we can change this into this pull byte array. Can't really do any of this stuff. Also can't really do any of this stuff. No reason to call clear since we're always doing things like that, or doing it like that. Yeah, and then it's just gonna be stream. We'll just work directly on the stream of bytes. Yeah. Okay, cool. And then here, we need to see what is happening here. So what makes this so special? Format 16 bits versus format 8 bits, which I think 8 bits is the default. So I think I need to do some additional processing here after this. So, data size. DST size is resized by data size times 2. Pool vector. Ooh. So we're clamping it and then encoding it as a uint16. And then we are then converting it. What? What? Isn't this something I could just do like that? I don't need to do any of this kind of weird stuff. Combine low bits and high bits to obtain... Okay, so I have the 16-bit value. Emulate signed... Hold on. Alright. Hold on. Alright, let's use this as a reference, I guess. We are programming. I don't need to combine the bits. I already have the bits. Don't worry. Actually, I believe that these are actually 32 bits. Yeah, these are actually 32 bits. Okay. I don't really know how that helps me, though. Emulate signed to unsigned 16-bit conversion. Combine low bits and high bits. So these come to me as pool vector 2. So vector 2 is a float, which is 32 bits. So I need to convert to 16? Is that what I need to do? Ooh? What's the max 16-bit value? Max 16, 17. Max 16-bit integer. Yeah. Okay. But I have 32 bits. I'm scared. I need an adult. Recording data. Ooh. Then encode it as an unsigned integer of 16. Ooh. Okay. I see what they're doing. But I don't need that. Encode... How do you encode something as a uint 16? What is this value? I actually don't know what this is. Why use this hexadecimal thingy over 6? What's the significance of this value? My computer science foo is pretty low. Pretty bad. Is there something special about the number 65,000? Number is treated as an unsigned integer in this case, which means all bit sets. So this is, okay, this is the 16-bit max. Okay. Wait. Oh, is that what that is? This is just this twice? Is this true? Oh, yeah, there you go. It's just that twice. Okay, cool. Who would have guessed? Okay. So how do I convert a 32? I don't know. I still need to figure this out. So 32 float to 16. Float 32. Float 32 to float 16. So we do need to truncate it. How would I do this? Help me. All right, so this is presumably in C, but we can still figure this out. Lookup table. We don't need a lookup table. What are they doing? What is this? Bit layouts? What is this? Or are these already encoded? These might already be encoded as 16 bits. I suppose that's also possible, right? So it's only encoding. I'm losing my mind. This is just bizarre. I guess we're gonna send it. All right, that doesn't work. Okay. So I don't think we need to do any of this stuff. So we'll say goodbye. Now we'll just print and then see what happens. Maybe the values will still be close enough. So start the lip sync stuff. Hello, hello, hello. I'm talking. This is me talking into the lip sync stuff. Is it not working? Probably not. Okay. So why is this not working? It might be because I need to have an audio stream player. So audio stream player. So we can create one of these. So audio stream player is equal to audio stream player. New, we need to set the bus. Bus is equal to bus index. Can you not do that? Oh, okay, hold on. What is it? Oh, it's a string. That's so weird. Okay. Bus name. Okay. I have that constant defined, so that should be okay. I think it should just be playing. Like, it should be muted, but like playing at the same time. So ASP. Well. Here we go. We can do ASP playing equals false. then yeah, so if we're not using lip sync, we'll just turn off the auto stream player. That's okay. And then if ASP not ASP playing, and ASP playing equal to true. Yeah. So that should be all right. Then we'll just need to add it to this node. So we'll hit it with an add a child ASP. Let's send it. Hopefully that's okay. Should just be playing now. Actually, it should not just be playing, but it'll just kind of be here. Yeah. So it's not playing. There's no stream, but we can turn on lip sync, and then hopefully this should start doing a thing. I'm talking into the mic. We're not getting any inputs. That's a bit unfortunate. I don't know. Play it. Just kind of force it to play. Why am I not getting any input anymore? I thought this would be easy. Okay. So it's here. Give it one more try. Give it one more try. So this is our audio stream player. Its mixing targets is stereo. It doesn't really matter what the mixing target is. We're talking, we're talking, we're talking. Use lip sync, that's correct. Stream pause, no. I guess we could just have this play in the background. It doesn't really matter. Actually, hold on. Let's just set this to play. That's okay. ASP audio play is equal to true. That's fine. That should just work. Right. So use lip sync. Now we're talking into the mic. We're talking into the mic. We're doing a thing. It doesn't appear to be playing. That's unfortunate. So there are like 2 audio buses. Mix target doesn't matter. Set playing, and we're still not getting any output. That's tough, man. That's tough. So it's not this. I mean, it is that, but it's there's a few other things in play. I would have to assume. There's no audio stream, I suppose, which might be a problem. Let me see. What was I looking at here? There was hold on. Let me open up my Discord. Someone sent me a message. I also sent me a message, which is my stream notification. By the way, I have a Discord. I don't know if it's really that useful or not, but it's there if you have any questions. You need to reach me when I'm offline. You need support on anything. You know, advice is free. Although I don't just work on other people's stuff just because. But, you know. Audio stream microphone? What is this? Audio stream microphone? Is this something I need as well? Audio stream microphone? What is this? Ooh. Audio stream microphone? Ooh. Audio stream player. Okay. I might need that. Yeah. Okay. That actually looks like it's might be useful. So ASP stream is equal to an audio stream microphone. And I guess, yeah, it'll just need to be existing. We just need to have it, I suppose. Yeah, so they add an audio effect capture. They mute the bus. Okay. Maybe this is what I need. We're talking. Not having any outputs. Good and bad. Okay, so I'm going to have to assume it's not working, though. Do I need to futz with any of this? No, it's working, right? And then there's the audio stream microphone. But I don't think I'm actually sending any input to there. All right. I know that it is possible to change your Godot code while it's running. However, when you're running as many threads as I'm running, Godot has a tendency to, you know, stop and catch fire. Not good, by the way. So let's see. Let's just print this stuff. See if we actually get any audio frames. Or it might be this part as well. It's like the volume is just too low. Possibly. We can also mess with that. So because what we should be seeing is some output. Yeah, okay, there's the output. It might be because of this. All right, let's get rid. No. This is the actual output. Right? This isn't the output from my. Yeah. That's not the output from my lip syncer. That's just the output from my microphone. Because we're printing the audio frames, just kind of like direct to console. So that's not super useful. They are just a bunch of vector 2s, and they're all negative for whatever reason. Or most of them are negative. Oh, I don't really know what that means. What does this mean? I don't know. Wait a minute. Hold on. Am I not getting anything because I cleared the buffer? Is it giving me a reference to the buffer? Okay, so it's not. Okay. Just had to make sure. You never know. Sometimes it do be like that, though. By the way, I think I need to just do this every single time. So we'll always clear the buffer no matter what. Just so that we don't accrue too many things inside of the buffer. Hello, hello. And this is me talking into the mic and doing a thing. I can see that when I talk over the audio max, I get more frames with actual data inside of it. Oh, hello, Bumsy. Hello, hello. How are you doing this evening? I am. One, very tired from work. But two, I'm trying to figure out what Godot is doing with this audio stuff. So I received a tip via Discord that I should be using audio effect capture as opposed to audio effect record. But now the problem is that audio effect capture just gives me the raw ring buffer, which is fine. It does mean that I need to do some conversion at this point as well, which is tough. It does mean I need to do some conversion, which is right, because what audio effect record gives me a pool vector of U8s, whereas the ring buffer will just gives me just basically the raw audio frames, which are pool vector 2s. So those are two very different data types, which is making things difficult. Right, like look at this. So this is what this gives me. Like, it's a fairly simple set of rules, right? It just looks at the buffer stuff, creates a new pool vector 2 array, and then writes all the pointer stuff to it. Whereas, look at this. Oh my god, what is this? Then it does like conversion from presumably a 32-bit float to a 16-bit U8, but it's not actually a 16-bit U8. It's like it's a U8, but like in weird 16-bit format. So I'm struggling. When I'm just working with straight numbers, I get kind of confused. So this is an approximation of what audio effects record does, which is the original implementation, right? So what audio effects record does is this here. Yeah, so audio effect record also uses a ring buffer, but then it stores the recording data inside of just a vector of, I think it's a vector of floats. Is it a float? Yeah, it's just a vector of floats. But then when I grab the recording, then it takes the current instance recording data, which recording data is the vector of floats, and then does some weird conversion magic on it. Actually, wait a minute. Yeah, wait a minute. Actually, hold on. Encode U16. Oh no. What does this do? I was struck by the idea that I could just do whatever they're doing here. So I can run this clamp thing, right? So we do for I in, write those down as notes. These are the notes. This is whatever I'm writing down here. I think the tough part is, well, hold on. I guess the tough part is like knowing if this is even close to what I need. So I am getting audio frames at the very least. You know, plus side is that I don't hear my CPU fan or my computer fan spin up, which is, we'll call that a win. Yeah, I've got it all in the noggin. Hello, hello, hello. Hello, 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 hello. We're getting some data. Okay. So, these are the final pieces of data. Some of these look very wrong, by the way. Yeah, see, some of these are 5. Some of these are 10 in length. Eh? These should all be just 5 in length. Eh? To sample. Ooh? Does data not always come to me in 5? Ooh? Something doesn't seem right here. Right? So looking at this, sometimes I get a buffer of size 10. Sometimes I get a buffer of size 5. Actually, not all of these are even in size of, in size 10. So this is 1, 2, 3, 4, 5. Actually, no, that's size 10. Why is that size 10? Right, like this one, of course, to sample gives me a buffer of size 10. Yes. But then I'm immediately passing this output to read 16-bit samples. Right, and then this is just a while loop, so this should half the size. And I'm not printing anything from there either. So the only print is the converted sample, the final sample. And then I pass all of that into lip sync, of course, but that's not super relevant. I need to figure out where encode uint16 comes from. This must be just like in the basic math class. Audio effects record. Okay, so we can close this. I guess I'm just gonna look at the Godot implementation of audio effects. or whatever that is, right? Where is encode? Where I was looking at it. Encode. Encode uint16. So this comes from, is not defined in this file. That's fantastic. Where is encode? Encode. Okay. It's probably not in resource importer. Probably not in audio stream sample, but it could be. This is audio. This is audio frame. God, this is what I hate about C, is that you can't just look at a file. It must be in Marshall's. It must be in Marshall's. Yeah, so I don't need to think any. Well, maybe I still need to think about this. Like, this is giving me audio frames. Then it resizes it, buffers it, blah blah. Then just slaps all of these into the return value. Yeah. Yeah. Maybe. Maybe. What the heck is this? So this presumably gets a lock on the... Hold on. So this is our return value for the audio effect capture. This locks the pool vector to array and gives us back a writer, it looks like. And then we use the writer to store the new vector 2s. Yes, so this doesn't do any conversion. Okay. All right, so that's all we need to know, is that the ring buffer just gives me the raw data. That's good. Where's encode uint16 coming from? That's where I'm interested. Does it come from here? It says undenormalize, no. Audio frame, no. I mean, that is what I'm using, but that's not useful for me at this current point in time. It's probably in Marshall's if I had to guess. So Core IO Marshall's. Core IO Marshall's. Sure. Let's look at the header. Maybe you should just capture it from Rust then. See, that's actually harder. That's actually harder. So like Godot provides like the device capture stuff already. So I don't need to mess with like the Windows, like which microphone do you have plugged in, or like on Linux it's different, Mac it's different. It's all different on every single system. So that's why it's nice to do all of this stuff via Godot. Is that Godot just, it does all the system specific stuff for you. The more system specific stuff I have to do via Rust, the more painful it's gonna be. But anyways, I found the function. It's this one. Encode uint16 given a what? Encode uint16. So it takes wait. Something doesn't seem right. What the? What? Wait. What? So they have a signed 16-bit integer. They clamp it between these two values. 32,000, 32,000, right? Or negative 32,000, positive 32,000, right? And then they pass it into encode uint16, where this is a pointer to an array What the This is, yeah, this is an array pointer. This is a pointer to a space in an array that expects a U8. But this is expecting a U in 16, but they're passing in an int 16. What? They're passing it this, what? This is not a U int 16. This is just a regular int 16. What? But how are they? Like, I know it's C++, so like, as long as this data, like the size of the data is correct, it'll just accept it. What the what? That's hard. That's difficult to understand. I think I get what they're doing. So when you encode it, that makes sense to me. Is it you're encoding it? It must be like a bytes, right? You're encoding it into bytes, sure. And then I can see here that they're doing a bit of pointer arithmetic as well. Yeah. So they just kind of shifted over, I guess. Yeah, maybe. So they bit shift to the right. By 8. What is this doing? They just do this twice. Oh, okay. I see. So this is what I need to do then. Is for results. Wait. No. Hold on. So I need to clamp. Alright, so here's the flow. Is I take this value. We're just gonna be pretty verbose. So this is I guess this is VL. And then we'll clamp this value. So this is I.x. Low of 32,768, high of 32,768. Right? That's your left. This is your right. Hold on. IY, because this is a pool vector 2 array, right? And then so let me make sure I'm doing this right. So what I'm doing is usually recording data is just these two lines here, but I'm kind of just like I'm expanding the functions kind of manually. So this should be correct, I think. And now we just need to do the encoding manually. How is that possible? It's stereo mic input. Yeah, I don't know. I mean that's what I'm getting though, right? That's what it's giving me. So I can prove it. So if you see here, that's exactly what they're doing, right? So this portion here, they are just reading from their ring buffer. Their ring buffer contains vector 2s. So buffered frame left, buffered frame right, and then they just continue to read the ring buffer, right? So that's what I was doing here on line 97 and line 98. So what I'm gonna do is just skip that step, and we'll just go straight to clamping the values from the recording data, which is what you were just looking at, right? Oh, it's this value. Hold on. Times 32,768. He's doing math. Everyone get down. Now we need to encode it, so we're gonna. I don't know. That should be a mono channel, which makes sense. I don't think it's a mono channel. So if you see here, I've been running this thing for a while. It's actually recording. No, it's mixing stereo. I actually don't know how it's recording. I don't know. I don't know. Maybe. I think audio effect capture just records in stereo, maybe? I don't know. That's just how they do it. I don't make the rules. Yeah, you know the rules, and so do I. Well, what is this? That pointer. Okay, so they dereference the pointer and then access the actual value. Then they increment the pointer. And then bit shift, bit. Why are they bit shifting it by 8? Like, I get this part, right? So they have whatever this value is, I guess. Like, we can even convert this to an integer, I suppose. Like, that'll probably be okay, right? So we'll just do this manually, right? So results. Results dot push back L and 0xff. Can I just do that in Godot? Oh, you can. Oh, nice. Cool. Very cool. But what is bit shifting pu int 8 to the right? Or no, p. What does this do? What does this line do? That's what I'm curious about. Like, this doesn't appear to do anything, right? Because this value is. Oh no, it's not. No, it's not. It's just how I'm doing this. Okay, so I think this should work. I think this should work. So we'll just push back R and something like that. I think that's okay. I don't know. That seems to be pretty close. Lowering the resolution so I can process fast. Yeah. It does make my life a lot harder. We're talking into the mic. Not getting any more data anymore. Hello. Yeah? What is your problem? Am I not talking loud enough, or is it just like struggling to keep up? Hello? Ooh, something doesn't seem right here. Hello. Test. Yeah? Wait? Something seems broken here. Don't cast to int. Yeah, it's possible I don't want to cast to int. But I do need it to be an integer. But I guess it'll auto-convert once I push it into the byte array? Maybe? I don't know. Oh, jeez. Okay, no. Invalid operands. Floats and ints. Okay. So that makes sense. What am I doing wrong here? So it's this one. I'm looking at this function. This just loops twice, which makes sense. And what I'm doing, I'm not... wait a minute. Hold on. So they have... recording data. Hold on. I think I've got it. So recording data. It gets set here. So this is what I'm working with directly. I'm working directly with the buffered frame, left and right. Yeah. but they're not doing any conversion here. Recording data, if we look at the header for this, recording data is a float 32. So that's a float 32. So that checks out because pool vector 2s contain float 32s. Ring buffer audio frame contains vector 2s. Yes. And we can verify this here. So audio frame, this is the C++. No, this is the header. Where is it? Where is it? These are just operators. Left and right sample, left and right. Yes. It's a float 32. We can treat it like a float 32. So, or a vector 2, which are float 32s in Rust terminology. So we read from recording data, which is what I'm doing here. This is our ring buffer data. We pretend like we pass everything to recording data, which is why we're doing it left and right, like so. So that's correct, I think. Right, because recording data. Oh. No, that's not correct. No, that's not correct. I see. The problem. Right, so this is recording data. So the recording data is made up of left and right. But you can see here that they're processing left and right individually, where I'm trying to process them at the same time, right? And so that sounds like the same thing, but it's actually not. So they process left, then they pass left, then they encode left all by itself into bytes. That is bizarre. That is so strange. Okay. So I need to encode left into 2 bytes, and I need to encode right into 2 bytes, as opposed to just trying to convert left into a single byte. Yeah. Oh, jeez. Who wrote this? When you record audio via mic, there should only be left channel getting the data, as far as I know. I think it depends on how you record it. Like, I can see that I'm recording, or at least my mic audio is going in as mono. So the values for left and right should be the same. So it doesn't make a huge difference. It just adds a bit of noise. Yeah. So like it depends on your audio setup. But I think if you're streaming, you should have your streaming setup record in mono anyways, right? Unless you like explicitly record on the left channel for whatever reason. Depending on your, yeah, if you have like a really fancy audio setup, so like you have like a left channel only, so that you're using less audio buses or whatever, then you can reroute that somehow via software. So it's technically more efficient because you're using less audio buses. Actually, you know what? I'll be right back. I'm going to refill my drink. BRB. Hello, I'm back. What I'm trying to avoid doing, by the way, right, like the easiest thing for me to do is to rewrite the lip sync stuff to just accept float 32s. I really don't want to do that. Because then all my values will be skewed, which is very scary. And on a hardware level, I'm not sure how it works on a hardware level, doesn't it? Software can make bus, copy, pass, etc. I don't know. Like I know that on a hardware level, you're correct, I think, but then I've set it up on a software level to just record in mono. Unless you explicitly split it at a hardware level, so then you have, I guess you have two mics. Yeah, you're right, yeah. If you want, you can either use a splitter to I guess, emulate left and right. Otherwise you would need two mics in order to actually get left and right input. Yeah, you're right. Anyways, that's neither here nor there. Even the cables will work that way. Yeah. I know what you're talking about, yeah. But I believe the input should be fine. I believe the input should be fine. Hold on. I need to get this equation down. By this equation, I mean whatever the heck this is. Jacks are mono. Sounds like Jack should stop kissing people. I don't know. There was a joke in there. I lost it. That was a joke about herpes. All right. Anyways, actually, is herpes mono, or is mono just something completely different? I've always considered them to be almost the same thing, but that might not be true. So hold on. Here's what I can do to emulate this thing. So we'll do this, and then do L. Can I just bit shift like this? Is this a thing I'm allowed to do? Look at that. You're just allowed to do it. Amazing. I love it. All right. So for J into. Yeah, because we do also need to do this in a very specific order. I was gonna say that we could just do the second for loop lower or later on, but it doesn't make a difference at this point. Or no, it does make a difference because we need to do this in a specific order. Otherwise, they'll be out of order. All right, so bit shift over 8. Okay, so that's probably okay, maybe. Let's see. Let's start recording and see what we get. Hello. Oh, look. Now we're getting like a consistent flow of values. Yeah, that looks okay, I think. I don't know. That's probably okay. That's better than what we were getting before, at the very least. Hello. Hello. Sometimes I get just an empty 5 index buffer. I'm assuming it's because read 16-bit samples doesn't actually work as I think it's working. You know what? Can't I... Wait a minute. Wait a minute. I just need a pool real array. That's what this entire thing is. That's what this is doing. Read 16-bit samples is to just read bytes and then give me back floats. Where the bytes are encoded as U16s, but they're actually U8s. Can't you write it to a file? So here's the thing, Bumdy, is that even if I wrote it to a file, I don't know what I'm looking at. Like I have almost no frame of reference for any of this stuff. You can listen. What am I listening to? You mean like listening to my own audio playback? I can do that, yeah. But like I still don't understand what that's supposed to do. Do you mean like read back in this file, like read in like the results and then see what it gives me? The raw converted audio? I guess that might make sense. Sure, the raw converted audio. And then yeah, yeah, that makes sense. Yeah, could do that. We're not going to though. I think what we're going to do is just monitoring on an audio. Yeah, like I get what you're saying, right? Is to see if the conversion, like it should still sound like roughly what I'm saying right now, right? Just a bit grainier because it's been converted. But I'm not going to do that. Like I think if I wanted to do that, right? I think I could. What I should actually do is take this plugin, Godot VoIP, voice over IP, and then just slap in my conversion thing there, because I can see from their scripts, right? They have like a voice instance, and then they have a audio stream generator playback to echo it back to you. Yeah, so like that's how I would test. That's how I would test this thing here, right? That makes sense. Don't know why you don't use it. I don't know. I've just been, the same way that I implemented this thing, right? Like, is my method the most efficient method? Not really, but is it good enough? Yeah. Makes sense to me. Like, if I really need to, I will. But I think I'm close. I think I'm close. Like, there's a lot of easier ways to debug, but we're not going for the elegant solution. I found a game made with Godot 2. Wasn't there's a few like PSP games, aren't there? Like that were made with Godot 2. Like the original engine authors made it with Godot 2. How do I grab this? For some reason, I can no longer open links that originate in OBS. Alright, please don't be porn. Okay, cool. Oh, this is Godot 2. It looks pretty sick. Look at that. Fast-paced platform about using colorful paint to uncover your surroundings. That's neat. Watch the video. I don't want to get DMCA'd. I can imagine what it does. Like this looks like a really cool concept. It's more of an artsy game for sure. I guess if we're not playing any audio, it should be fine. Yo, this is made with Godot 2. Ooh, it's very Meat Boy-esque. It's like, what if we made like Meat Boy, but like had more colors other than red? That's a cool idea. It's like, like someone played Meat Boy, Super Meat Boy, and was like, man, my favorite part about this game is just painting the entire level. That's neat. Yeah, 2015. Yeah. This is made with Godot. How do you know it's made with Godot? Did they just like say it was made with Godot? Forum. Okay, cool. It's pretty sick. That's pretty sick. Oh, and I just saw the Meat Boy thing. Yeah. Like the Meat Boy key cage and all that. So it is like pretty much just ripping off Meat Boy as well, but it's Meat Boy but colorful. I get it. I've never actually beaten Super Meat Boy. I got too frustrated on one of the, I think it was one of the shadow levels, whatever they're called. And just rage quit and never went back. I should finish it at some point, but I won't. All right, so here's what we're going to do, I think. So I do need to encode this as a or it needs to, maybe all I need to do. Oh, you know what? I think I got it. I got it. Pool real array. Okay. Pool real array. So we're just converting this to a pool real array. And then we're also going to be converting it to a range of -1 to 1. I don't know if we need to do this part, right? Because we already have a float. These are already floats. We don't need to do any of this. We do need to clamp the value for some reason, I think. Yeah, maybe. Maybe we don't need to clamp it? Hold on. We're thinking. I think we just need to do this part, right? So we'll do results push back. This is already a float. Well, then that also means that we don't need to convert to integer anymore. Does it make sense to use negative? I don't know. That's just what the algorithm that I'm using uses. So the algorithm that I use accepts values from -1 to 1. So I guess that's just how a lot of audio algorithms work. Is just -1 to 1. I don't know. I suppose it makes sense. Like it's somewhat statistical in nature. But if you want like a more specific answer, I do not have that. Apologies. Wavelength. Yeah, audio engineering is just not something that I'm familiar with, like, in the slightest. But it's also like, I know if I don't do it myself, then no one will ever do it. So, here we are. We're doing it. Yeah, because I think the problem with a lot of open source software is, you know, you're just always continuously waiting, like, oh, you know, I'm not going to do it. Someone else will do it. And then no one does it because, you know, bystander effects. Hello, 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 hello. I think this actually looks okay. We're getting a lot of output. Oh man, look at that output go. All right. I don't know how this helps me though. Why am I not getting any values back from my lip sync though? But yeah, no, it's definitely what I think a big problem of a lot of open source projects is that people just kind of hope that other people will do it, which is annoying. Where it's like everyone has plans, right? Everyone has big aspirations, but they need people to actually implement the grosser stuff. It's like, oh, but no one wants to actually implement like lip sync, right? That sucks. That sucks. And that's kind of stuff that I'm okay with doing, right? And of course, once you're kind of scraping the bottom of the barrel like this, right? Like almost 100% like the wrong person to be doing this, but I'm also the only one willing to do it, so, you know. Once there is a project out there, then the hope is that other people will be willing to, you know, like, oh, maybe you don't want to do it like that, maybe you want to do it like this. You have other scene where it shows the letters captured, can't use it? No, I can't. I actually can't use that because that uses audio effect record. So I could, but it uses the same algorithm, so. It uses the same algorithm implemented in Godot. So I guess I could try to patch that one. Yeah, I suppose I could try to do that, yeah. I could try to patch that one to use audio effects capture as opposed to audio effects record. So we'll go into here. I know that they have a default bus layout. Get rid of record. We'll add effects, capture. This kind of breaks their script though. So let's see. Bum, bum, bum. Where is it? So this is audio effects. Effect capture. Right. You can get the capture instance. Why would you want the capture instance? Eh? What does this give you? Oh, it breaks. What a great feature. So there's your effect. This should be broken. Let me see if I can find the other bits. All right, yeah. Set recording. Okay, so I just need to make the two of these play nice. What did I do? So this is if effects get buffer length frames is greater than or equal to buffer. All right, what is buffer supposed to be? Update frame. Update frame. Then all of this is also broken. Effect does not have set recording effect. This should just be audio sample. We don't want to use audio sample either. This is why it's hard to patch other people's code. Var data, or yeah, data is equal to effects get buffer. Needs to be of length update frame, and then of course we want to destroy everything afterwards as well. We don't need any of these bits. Then effect, let me see, where is this if statement? Yeah, so effect clear buffer, something like that, right? Yeah, that's in the same thing. Yeah. So if data, well, we don't need to have this if statement either, right? Because we just know that there will always be data. There will never not be data. Is this correct? Yeah. Sample array. Okay, so now I need to copy and paste over my conversion thing. So this is to sample. This one. Where is read 16-bit samples? So this is their implementation. Resize. This is updates. Update frame times 2. That's just what they call it. We'll call this to sample. Let me see. Sample array. Ooh. Alright, so we can get rid of these as well. So var sample array is equal to sample data. I think that should be okay. This should be okay, I guess. Maybe. How do I set the recording active for this? So this is an audio stream. That's an, oh, okay, so they have an audio stream microphone as well. I guess it'll just work. I don't know. Record. Like, there's no way for me to turn on recording, I think. Press it. Well, hold on. How do I set this to the start recording? So, no, this is audio stream sample. How do I get, audio effect capture? I guess it doesn't matter. Yeah, okay. I guess we'll just send it. Yeah. Send it. Then record. We're recording. Nothing's working. We're not seeing anything. Okay, but I am occasionally getting data points. So I think it has something to do with how I am doing the conversion. So that, I guess that's helpful. What am I doing here? So I'm getting nothing. That should be fine. No? Right? Like, this is, all we need to do is clamp the data. Like, I don't do anything else to it. Like, we multiply by 32. Oh. I see. There's no way that broke everything, right? I fat fingered it. Hold on. Hello, 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 hello. Okay, that's good. That should be the same. This is the same thing, isn't it? Like, it's not exactly a 16-bit value, but it's close enough. Read by packs of 2 bytes. But we're converting it to... So, combine low bits and high bits to obtain a 16-bit value. That clamping... Are you sure that clamping line is correct? Yes. Well, because that's what they're doing here, right? Is that they're clamping it to be 16 bits. And then this application runs off of 16-bit samples because that's what these are working off of as well. Presumably, every single function expects a 16-bit value that we then cast to a float. I suppose we don't need to clamp it. Yeah. Yeah. We can try. I guess we don't need to clamp it. We could just send it, right? So like this will also work. I mean, not like this, but like hit it with an i.x, i.y, something like that. And then see if this works. Hello, 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 hello. This is me talking. Yeah. So I don't think that's doing it. This is correct. This is all correct. We get the buffer. We convert it to our appropriate sample array. Then we calculate our RMS sample array. Oh, it's a sample size is too small. But wait, I thought we were waiting for... Wait. Wait. Brain is breaking. Does this hold on. Hold on. Update frame. Is that why? Oh, hello, green coder. Hello, hello. I think I've got it. Yeah, maybe. I'm still working on the lip sync stuff, but I'm changing the implementation of the lip syncing recording function from Godot's audio effect record to Godot's audio effect capture. So I think audio effect record is good for recording like one-off things that you do once every 30 seconds or whatever. But if you need a constant flow of information, then you are better off using an audio effect capture. But the problem is that audio effect record does some funny stuff when it starts to, when you get the data, right? So it does like a conversion to 16 bits. So it converts it to a U16, which it then encodes into bytes, U8s, whereas getting the data from audio effect capture just gives you an array of vector 2s, which are float 32s, F32s, which is confusing me. Because ultimately my goal, at least in this equation here, is to get a vector of, or an array of F32 values. So I'm already there, so I don't even need to go through most of this stuff, right? Because I already have a float. That's okay. I think the problem is that I was not recording enough data. So let's do that. Oh, geez. Okay. Non-existent function slice in base pool real array. Oh, okay. He's done it, I think. All right. That was it. Amazing. Read a lot about FFT and DWT. How about DMT? Maybe some PCP as well. As long as we're going hard on the acronyms. I don't really know too much about them, except that they do some sort of data cleaning on things to make audio processing easier. NFT, oh yeah, NFT, yeah, it's also a good one. You know. Discrete wavelet transform? What is discrete wavelet transform? How does that compare to, FFT, fast Fourier transform, and then there's also Mel, Fourier, something. What is MFCC? God, anything that's just overloaded with acronyms immediately makes me distrust it, because it's like, hey, you're definitely trying to like scam me out of something. Discrete wavelet transform. Ooh, discrete wavelet transform. Let's just look at the Wikipedia. Numerical analysis. No, is this not how this works? Functional analysis is any wavelet transform for which the wavelets are discretely sampled. As with other wavelet transforms, a key advantage it has over Fourier transforms is temporal resolution. It captures both frequency and location information, location and time. Sure. Hello. Oh, hello, Arrow. How are you doing? What I am working on today is still more lip sync stuff, but I am changing it from audio effect capture, or from audio effect record to audio effect capture. Oh man, there's just so much stuff you need to know. Wavelets provide a better information about locality over time. So yeah, so basically it's like they have time information as well. That's basically it. I would look to know the difference. There is, so basically audio effect record is good for, if you want to capture like like 30 seconds of data and then write that data to a file, whereas, what I just described was for audio effect record. Audio effect capture is good if you want to transmit that data continuously and just kind of, have it running in the background, right? Because with if you try to do the same thing with audio effect record, like how audio effect record works is that it starts up another thread and then shuts it down every single time you want to read the data. Yeah. So you want to use capture instead. But the problem with capture that I'm running into right now is that audio effect record, does some funny data cleaning. So it converts. So they both capture data, right? So audio record and audio capture, or effect capture, effect record, whatever, right? They both capture the data in the same way, but the way that they give it back to you as the end user is different. So audio effect capture, which is what I want to use, gives me back just the, like, it gives me a buffer, an array, basically, of vector 2s, whereas audio effect record gives me back bytes, which is weird. So I figured out the algorithm. I'm just trying to make it work now, because now I can't use the previous thing I was doing either, which is tough. So I don't need to use this function anymore because we're not getting bytes, or we're not getting bytes encoded in 16-bit format, which is just bizarre. I don't know why Godot does that, but I guess it's for data transfer, even though recording is not for data transfer. So I don't know how that works. So like for recording, it gives you back bytes, which are better from what I understand, bytes are better for data transfer. But I'll actually capture gives you back. Well, and capture, which is meant for data transfer, actually gives you back just floats. So it's like opposite. It's the opposite of what you would use either of them for, which is weird. But anyways, I think this should work. Let's send it. So this is the test application, which is what my algorithm in Rust is based off of. Might be how the OS provides the data. I don't think it is. That's just how Godot works. From looking at the source, that's just how it works, right? So I can see here, right? Like this, this is the implementation for audio effect record. So check this out. So recording data, already verified, buffered, or no. Buffered frame is an audio frame. Audio frame contains left and right, which are F32s. Then recording data is a vector of F32s. And then once we get the recording, it returns a pool vector of bytes, U8s, which is weird. Anyway, send it. Invalid operands nil and nil in operator times. All right, well, that's fair. Where is my sample? My sample array is huge. All right, so it's just a bunch of null values. That's good. Oh. How does that happen? Off topic or anything. Remember those server shenanigans I was doing? I do remember, yes. With TCP stuff. Were you able to... Ooh, you got it working. Fancy. So you're able to send the request to get a token. It redirects the user to like a web page. They click authorize. Oh, and then you're able to intercept the callback and get the code from that. Ooh. Ooh, that's good to know. Get the auth code in Godot and ask Twitch for the token. Yeah. The token part I got working. It's just the auth code is the hard part, but okay, cool. It's good to know that that's possible. Good to know that's possible. Not working. Sounds like that's something I should actually implement for this thing as well then. Now that I know it's possible. And now that I also have a rough idea of how you did it as well. Look at that. And making a server was easier than I thought. Yeah. So hopefully then I can also implement that for my application as well. Even though I don't really don't have any greater desires for this. Let's see. Why am I not getting the appropriate data? Maybe I shouldn't resize this. Maybe I should just let this auto resize. You know what? That's probably it. Hello. Oh, I saw it. I had a piece of data. Divide by 0 in operator this thing. RMS is 0. Okay. Just happy to get it working. Yeah. Well, that's the best part, right? Is that when you work on tooling, things just work and it's obvious when it works. Or I guess it's easier to call something done when you work with tooling, which is always fun. So congratulations. Did you get the rest of the Twitch stuff working as well? I guess I'm getting a lot of zeros, I guess. So I need to do a 0 check. RMS. Is equal to 0. Just return RMS. I think that's unlikely. Not quite yet. Spent a while just tweaking stuff with the auth code and automate for easier testing. Got to get the WebSocket connection set up and they need to parse it. Yeah, that's the second tough part. That's the second tough part. And also with Godot WebSockets, Godot WebSockets assume that you are reading bytes by default, which is weird until you realize that the WebSockets that Godot uses are meant for like gameplay, not for actual WebSocket connections. So you need to switch them over to using text connections, not bytes. But then after that, I mean, I've already written the code before. It should work. I can guarantee that it's possible. Hello, hello. This doesn't seem correct. Yeah. Well, I mean, like, that... I don't really know. So I can see that the waveform is changing when I talk. But I'm not sure why. Like, it should be giving me... I know that there is also like there's a pretty good amount of background noise, and my microphone is also like really sensitive, if only because I've turned up the sensitivity. How to switch it to a text connection? I've just been converting with UTF-8 string functions. Well, it's because of, well, no, because what you're doing, right, is an HTTP request. So all HTTP requests are sent as bytes. But WebSocket connections are slightly different because you need to like kind of explicitly handle the handshake there. Whereas if you just send like a REST request, it just kind of assumes that you know what you're doing. So it's like, all right, here's the handshake, but then like whatever you do with the data is your problem. Whereas WebSocket, you need to explicitly define how you receive the data. Yeah, so WebSocket connections are done over TCP. So REST and WebSocket both use TCP, I think. Yeah. But the way that you maintain the connection is slightly different. Can you unplug your mic? I can do this. Seems a bit sus. Seems a bit sus. Like it's clearly getting some data. Like when I talk, the waveform kind of changes. Like if I do an oh, well, maybe not. Maybe not. Ooh. Is it doing it based off pitch? That doesn't make sense. It should be based off of, if I do like a T, 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 it should be the I. T, 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 T. Coo. Yeah, like the U is obvious. I don't know. Ka. Ka. Ko. Po. It's not working. I'm not able to get the O sound. Yeah, I don't know where the rest of the wave is coming from. That's a bit weird. Like this looks okay. I think, you know what? If I go back to this application, hold on. I got it. I need to change the buffer. 1024. That should be okay. Then this is buffer as well. Oh, you know what? It might be the buffer length. I need to explicitly set the buffer length as well. Possibly. So where's my ready function? So we do effect. Where is it? Length. What did I call it? Buffer length is equal to FFT samples. This might work. I don't know. Send it. Hello. Ba bo boo do lu tu. How are you doing FFT on your sound data? You cut your data into short segments which you analyze separately? I don't know. This is the equation, right? If you want to look at my reference, let me see. I can find it for you. It looks worse. I think it looks more accurate, to be honest. Yeah, by the way, this repository doesn't have a license on it, but it's okay because I got their permission to use it. Screenshotted, just in case they get antsy about it. I think it looks better, by the way. I don't know. At least I'm not crashing like every few minutes. When you talk wave magnitude lessens. Well, I think let me turn off my mic again. Yeah, I don't know. I don't know. I wonder if it's because of the... Like, this looks okay, I think. I don't know. But it looks like possibly something to do with the root mean square calculation that's kind of messing things up. Maybe capturing the music, if that makes sense. You know what? That could be it. I don't think that makes sense because it should be listening from microphone, but I have no idea. I'm mad. I'm mad. I'm mad. It's been recording my music this entire time. Silence doesn't give me a wave, it just keeps it drawn on screen. So that makes sense. Like I think I can prove it if I go back to this. Turn this off. So now we have nothing drawn on screen. Let me turn off my mic again. flatten the curve. Yeah, yeah. Down with the establishment and all that good stuff. Yeah, I don't know. So I turned off like all my input. I don't have anything else making noise, right? Yeah, like it's really only voice meter and then like me that's making noise. Do you have mic gain? I do a little bit of mic gain, and then I also have like a brown noise generator in the background for sure, which is probably messing with this part. Probably this part, the RFFT. I guess this one doesn't use MFCC stuff, but maybe segmentation of sound data, maybe artifact from that. I'm not sure. I don't know. Like, just tell me what to do. I don't quite understand. Like, I guess there must be like some sort of like passive gain from this thing, whatever. Like the audio stream microphone, whatever that is picking up, it must be doing a thing. I don't know what exactly it's doing though. So we can look at. Oh. There's no audio effect microphone? Eh? Reverse fast forward your transfer. Yeah. If you unplug the mic, the gain might still get weird noise. Yeah, it's getting something from somewhere. I don't know where audio effect microphone is defined though. Do you have FFT? I think, yeah, there are just regular FFTs somewhere. Maybe, no? I don't know, maybe not, I'm a liar. I know, I do remember porting an FFT function somewhere. Yeah, so they have an FFT here, but then they only really use it in their, oh, this is reveal, or real FFT. Yeah, okay. So they do have FFT, but then they do a thing. I don't know what they're doing though. Like this code is what I linked in chat. So like if you want to look at like what my implementation is doing, like this is it. It might be amplified by the Godot. So what I need to find is like what the heck is audio effects microphone? Like what is the audio? Oh, it's audio stream microphone, not audio effects. Okay. Audio effects. So this is audio stream. Audio stream microphone. So this is audio stream playback, resampled. Audio stream microphone. Don't quite understand this. Sure. Oh, this is audio stream playback microphone. Well, this is audio stream microphone. Okay. Which is a set of pointers to audio stream playback microphone. Instance playback. Like this shouldn't be. This looks suspect. This looks suspect here on the right. I suppose what I could do. So audio stream record. Do I have a handle onto that? Audio. Audio stream record. Yeah. Okay. So. We can do this, right? So we'll default audio stream record to off, or we won't autoplay it. Then we'll do audio stream record stop. You can debug your code by first displaying the source before FFT in the silence. It should be flat. I think it's this. I don't know. I don't know. Like. It shouldn't be recording by default anyways, right? So like, you can see here in my process function, which is the equivalent to Unity's update function, right? Is that we do like an if statement, an if check, is if we're recording already. So we shouldn't be drawing anything because we only draw if we're recording. And recording is Set to false, right? Yeah, so we default to recording is false. So we never should have drawn anything in the first place. I think what happens is Godot is just getting some... I actually don't know. I actually don't know. Well, no. In the silence. No. That what I was just talking about. The last like 10 seconds are unrelated. Ignore that. Anyways, I'm turning off my mic. I think I got it. I think I got it. So, it looks like when there's no input whatsoever, the ring buffer is just filled with -1s. So that might be doing a thing. And then it looks like there's some sort of like built-in buzz somewhere. I don't know where the buzz is coming from. But there must be some sort of buzz. That's tough. But I think at the very least, this looks more correct, right? Or it's not drawing anything anymore. Oh, because I'm not actually recording. So it doesn't know, so it just kind of wildly oscillates. So if we do this... Oh, geez, stop. Stop printing. I think my calculation is correct here. So we record. That looks okay. Right, I mean, there's like an unreasonable amount of buzz coming from somewhere. But whenever I talk, at least I can see some like actual peaks form, which is close enough for me. I don't really know. It looks okay though. I think I've updated this buffer to be 1024 as well. So we can start talking and then we'll get some sort of output, maybe not. Printing too much stuff. Can you play back what's recording? I could, but I'm not going to just yet. Hold on. I believe in me. You know, don't believe in yourself. Believe in me who believes in you, etc., etc. Where is my buffer? Buffer. So this is buffer times 2. Oh, and then it's broken on the Rust side too because it's expecting a buffer of size 5. Okay, hold on. hold on. Job. This is expecting FFT samples. Where is FFT samples? Where did I pull this from? Model. No? How about update frame? Where's update frame used? Update frame? Okay. Do I use this at all? I don't think I do. Like, I should just be copying this from a typed array. Maybe I'm using this in algorithm? No. I'm using model, so data points, inverse log 10, and pi 2. Hold on. We can figure this out. So this will be... What am I looking for? Buffer. All right, I'm not using that buffer value. I don't think I am. Like if I just get rid of update frame, what happens? All right, so job was using it in one place. Buffer. No, what was it called? FFT samples, FFT samples. So these are the same thing, so we'll need to recompile really quickly. Not this one. So this is real-time lip sync. Cargo, build, release. Grab these two folders. I really do need to write a script to do this, but I won't. All right, it's currently loaded by the program. Okay, so say goodbye. Say goodbye again. Load you in. Let's see here. Open up Godot. Open up OpenCFace GD. Master branch. Actually, this isn't even master branch. This is more than master branch. Hello, hello, hello. I'm getting some data. Or I was getting data. Where's my data? Where is it? Free me. Did we crash? Is it struggling? I don't really know what's going on. Looking at that. Because I'm not speaking. We're using facial tracking or just audio from mouth flaps. So that's what I'm working on right now. So right now, mouth flapping is only done via facial tracking. What I'm working on right now is real-time lip syncing. So based off of what noise the algorithm thinks that you're saying, it will change the mouth flap shape. But I'm struggling with that right now. Like it wouldn't be too hard. To just make it so I could just listen to your mic volume and then make the mouth flap with you, but then you don't get the fancy mouth shapes. Cool, what model are you using for facial tracking? So this is the reference model, Alicia 5.1. So of course it's the reference model for VRM stuff, but you know, you can also just load in the duck. This is completely separate from what is running here as well, by the way. So this is the master build. This has a lot more fancy features in it. But this is the current release, which is 0.7.3. So this is the duck. Not a VRM model. This is just a regular 3D model. Then you can see that it also works for fancier models like this. Oh, okay, you mean like actual models. I'm using OpenCFace, so you can find this application. I wrote this, by the way. Let's see, OpenCFace, check this out. So all the details are there. I'm using OpenCFace for facial landmarks. The algorithm I'm using for lip syncing is based off of this one here. And then also based off of ulipsync as well. So here's the open issue that I'm just tracking stuff on. So that's it. I don't know. I mean, that's pretty much it, right? The code is free and open source as well. Everything is open source, etc., etc. Look at that. Real-time lip syncing. This should, in theory, work for anything that has a CFFI, which is pretty much everything, or anything that can link to a dynamic library. Yeah, so all the code is written in Rust, or I've converted the GD script code to Rust code. So in theory, this works. I think I'm just passing in the data incorrectly. Yeah, I don't really know what I'm doing. I don't do audio engineering. I just do my best. GD native. Oh yeah, definitely GD native. That's my My favorite part about Godot is that it's just easy to link new stuff in. You don't have to worry about a fancy FFI stuff. Like, I know that you can do CFFI with like C#, but it's just weird having to wrap the DLL like that. Or pretty much you always have to wrap your C libraries in like a C# thing if you want to do it in like Unity, right? Whereas Godot, you can just access Godot stuff from your Rust code, which is neat. Yeah, you know, I do a bunch of other stuff as well, like this. Check this out. Whee! Look at that. This is written in Godot as well. Also uses Rust, but it's not. I guess it's not actually running anything. But I don't know. Like, look at this. It's like when I talk. Yeah. It's when I talk, it stops running the job for whatever reason. That's actually kind of weird. That doesn't make any sense. And one of your links answers this, but what's the theory behind real-time lip syncing with audio as some sort of format detection thing? I have no idea. You're asking the wrong person. All I've done is I've taken their algorithm and converted it to Rust. So, I mean, I guess you can just look at the algorithm there. So, if you want to walk through the repository, or if you want me to walk you through how everything's structured, I can definitely do that. So librs, that's your main entry points for Godot. LipSyncRS, that's the main class that Godot has access to. I run lip sync jobs based off of a thread, so each job runs on its own thread. How nice. Or no, there's only the one job. So LipSyncRS creates a thread, creates job. Actually, where do I start the thread? I forget. I start this thread somewhere, but I don't remember. But then it has a two-way channel, two different channels actually, that allows me to communicate it with the job, even though it's running on a thread. So each job only lasts for 1,024 frames. So we just hit executes every time that it's ready for a new job. When this is done, we're then able to query that information back from LipSync. So LipSync has a job. There's a join handle, which is basically your thread handle, right? So you always need to pull for new data from your job channel. Yeah. I'm trying to remember. I wrote this like last week and I've already forgotten how it works. Yeah. All the algorithm stuff is in algorithm RS, as you might have expected. All the model stuff is just in model RS, as well as the default estimations for the various phonemes. I don't really know how these work. These are just the defaults that were provided by the library that I'm using, or the reference library that I'm using. Don't know how that works. What else is there? Yeah, that's pretty much it. I don't know how exactly it works. I mean, the code is there. Don't know. Yeah, I'm more of a visual kind of guy, but people were asking for this feature, so I aim to please. I haven't changed anything, so I don't know why I'm even trying to run this again. I think it has something to do with like the lip sync manager stuff. Oh. Needs to be greater than 3. That's why it wasn't working as I expected. So we talk like this. Talk. We're talking. Hello. Okay, so let's stop this, because we can only run one tracker at a time. So let's run this tracker. So this is the debug one. Am I running on the right one? All right. transparent window. It's confused me. All right, start the tracker. Alicia solid is pretty good. Load the preset. Oh geez, it's really close to the camera. So now we're talking. Bleep bloop bloop bloop. It's a little suspect for sure. Do you know what data points is? Yeah. So I wrote the entire thing. Data points is just a struct. It's supposed, so what they're using here in the reference model on the right, they're using vector 2s. So instead of doing that, I've just created a new struct called data points that allows me to do stuff. Yeah, I don't know. I mean, that's pretty much it, right? It's essentially the same as a Godot vector 2. So it wraps, it's a tuple struct of an F32, and it just kind of lets me know what I'm passing around. What do the two values correspond to? I have no idea. Probably not what you wanted to hear, but I don't know, right? You would need to look inside algorithm. I think it has something to do with, yeah, the FFT, fast Fourier transform. RFFT is real fast Fourier transform. Oh, hello. Hello, George. Oh, it's you, George. Hello. Yeah, so this is what I have working so far. This is not actually how you should be doing this stuff. What I should be doing is I should be modifying the interpolation data. Let's do that. Yeah, I thank you for the follow, by the way, George. Much appreciated. I'm assuming that you're the same George from Discord. But yeah, Vile Osprey, if you want to look through the code, like if you're familiar with C, this should be fairly readable, I guess. The only difference with Rust code is that once you mutate any variable, that variable is considered consumed, right? So that's why you have a lot of these other functions. So like, you don't iterate over the data variable directly. You iterate over an iterator over the data variable. But other than that, I mean, once you wrap your head around, you know, consuming variables and lifetimes and all that, Rust is pretty nice. I know Rust is cool. I'm just trying to figure out what the algorithm is doing. Yeah, I mean, you're asking the wrong person. Honestly, I don't know. I don't know. All I know is that it works. All right, so what I'm going to do, I'm turn this off, turn off the tracker, turn this one back on. This actually used to be a huge bug. Like, it didn't used to work. How this used to work is that once you stop the tracker, the entire tracker logic would break. That's something that's only been fixed like in the 0.70 release. Maybe even after that. You can take a WAV file with known values and convert that to bytes or float values to the Rust code and see the outputs are correct. I guess I could, but I would need to build that in, and I don't feel like doing that. Right? Like it's like, yes, like the answer to any like programming question is yes, it's possible. Do I think it's worth, you know, writing? Probably not. No. It's honestly probably like a lot more trouble than it's actually worth, unfortunately. So, you know, I think if I'm like, you know, if I'm getting paid to do something, then yeah. Like for work, I'll build out whatever I need to, but in my free time, I'm just, you know, we'll just send it. I don't care. We'll make it work. Thought FFT should be taking care of the Rust code. Yeah. Yeah, the Rust code does take care of all the FFT stuff. Yeah. Fast Fourier transform and all the other algorithm stuff, which is very slow. Actually, hold on. Let's profile that again, by the way. So previously, process used to spike to like 50 milliseconds utilization. Now we can just talk into the mic here. We're getting inputs. Oh, it's beautiful. Look at that. Absolutely fantastic. Now we're no longer having the huge process spike. If anything, it's gone up by like, oh, one big process spike. That's okay. We can handle a little bit of stutter. Yeah, that's not bad. I knew what I was doing. I knew it was Godot's fault for being slow. All right, so I think my algorithm is working. I just need to fix this part. Is it still capturing the music? It 100% is still capturing the music. I have no idea how to make it not capture the music though. I guess you would need to... I would need to look that up. I have no idea. Not this one. I think I'm good on a lot of the conversion stuff. Check the capture device. Yeah, well, I know that it's just capturing like basic audio, right? So if I look at my volume mixer, it's 100% just capturing my audio device. But I don't really know how to isolate this stuff, right? Because if you look at voice meter here, running this is not accurate with non-flat spectrum. I don't know what that means. Running Godot audio processing alone is not accurate. What does that mean? There's what you hear kind of stuff. Yeah, I don't know. That's getting into stuff I don't really understand. So this is what I'm working with, right? This is my virtual out. I'm piping my ASIO input, which is my physical hardware box, along with my Windows input, which is the music. They both get piped into the same output. So there's device selection in the mixer. Is there device selection in the mixer? There might be. Nope. I don't know. Capture. Record. No. I don't know. I don't think so. There must be a way to like find it, but I just don't know. You only have one bus? Yes, I know that. Yes. So that's what it looks like to the untrained eye. But I actually send all of these in the ready function, so don't worry about it. We have already solved this issue. I just speculate. Yeah, it makes sense that there should be like some way to specify the capture device. I just don't know how to. Godot audio capture device. That sounds right to me. How do I change the audio input device using the audio server? I have... okay. No answers. Capture set device. Oh, is there a way for me to do capture set device? Audio server. Capture. Set device. Swap bus effects. Audio server is setting the device. Yes. Oh, capture, get device, set device. Okay. Cool. Yeah. Okay. So we can... I don't know. That makes sense, I guess. I guess we can do that. So let's just hit it with an audio server. Get device list. We're just gonna print this for now. Okay, setting the device. Yes. Found that out. Okay, so I have a lot of devices. I think I want to listen to speakers, Focusrite USB audio. So instead of doing this the good way, we're just going to do like this. Set device. Set capture. What is it? Capture set device. Oop. Is that how that works? That doesn't seem right. I guess that's how it works. I think it's basically just converting an audio clip of a certain size to a frequency spectrum and then just outputting the vowel, which is the closest match in the frequency domain. That sounds correct. Yep, that's my understanding as well. How exactly it's doing it, I'm not sure. What I do know is that the current implementation that I'm using, this is the old school way of doing it. How you would actually want to do this nowadays is, you know, have some sort of AI, you know, train an AI on this, and then have the AI, you know, figure out the correct sequence of transforms, right? So you would let the AI figure out this stuff, and you would train it against various vocal graphs. So then the AI would presumably also give you these values, your estimates. But I don't like. Do you know of any free and open source AI tool that does this? If so, that would be fantastic. I could just use that instead of fumbling around with all of this. But as far as I know, these are the only two, like, real time and then free and open source, or at least things that I've gotten permission to use. So there's Ulip Sync and then Godot audio processing. Other than that, I don't have anything else. All right, give me 1 sec. Let me check something really quick. I'm also super over time. I also have like real work I need to get to. I got grilled this morning by my boss because I am behind. I'm behind schedule. No, I'm behind schedule. No. I was hoping that you would have a demo for me. That's the wrong guy to do this stuff. I don't know how your Rust program works. I was hired as like a QA, like engineer. I was to make like Python test harnesses, not to work with your weird Rust application, which is like it's like a microservice that has been split into nano services, which is bizarre. You do QA? I do QA and then also like software consulting. So I can't tell you the company I do QA for, but I can tell you that I also work for, or may or may not also work for Red Hat, which is, you know, just based off of my name. You can find that. No, I don't mind it for the most part, but audio classifier. Oh, okay. That's what these are called. Not lip syncing. Cool. So open source. Yeah, but I do QA, but they pay me pretty well. Although I was able to argue up for the same pay grade as a software engineer, so I don't really care. It's the same stuff for me. Oh, cool. Apache 2. What is this? Please don't be Python. It looks like it's probably Python though. Let's see. Deploy from key, OpenShift. Did you know that key is actually pronounced, like, it's not pronounced quay, it's pronounced key? Like, key is like it's not even like a new word. This is an old English word. But it has been bastardized in English to just be like K-E-Y. But quay is actually pronounced key. So like the Florida key should be Florida quay. By the way. Audio classification, GitHub topics. Oh, Irvin's, well, this is, I don't really know what I'm looking for. I don't know anything about audio. Using Keras. I'd rather not have any more Python dependencies. Something that's nice is that I'm able to use like native code. God, no more Python. Need less Python. No Python. No Java either. That was in Flutter. Found the paper your algorithm is evidently based on. Oh. Don't really want to download it, but let's see. I don't know. You're talking to the wrong guy, right? Like I do. No, that's not how this works. I don't know. Let's just look at it. Yep, that's a paper. MFCC, yep. Mel Fourier something. Cepstrum. Artificial neural networks. I don't think this one uses any neural networks. Like, I'm pretty sure this is just raw MFCC. Like, this is like old school stuff. Yeah, anyways, I don't know what I'm looking for. Jupyter Notebook. Yeah, anyways. That's cool. Did I get around to doing this? All right, let's test this out. And by test this out, I mean I'm gonna mute my mic. But I'm gonna keep the music going, so give me 1 sec. Okay, so this appears to be a Godot problem. I don't think capture set device is actually doing anything. Or maybe it doesn't even like report errors if it didn't work. That's also possible. Like if I did, like I can check to see what the default capture is. If we do audio server, capture get device, and then we can just check it twice. We'll see what it is. Won't do anything. Hey? It didn't even work? What? Oh, I need to print. Yeah, my bad. Oh, that's neat. Okay, so it just gave me default twice, which is, you know, you don't need me to tell you that that's wrong. Yeah, it's an array list. It's a list for sure, right? It gives you an array of strings. Capture get device list. But in order to do capture set device, you need to pass in a string, which doesn't make too much sense. There must be a bug then, right? So we look at 3.4 servers, audio server. Audio server? No? Where is it? Audio. Alright, so we're looking at the C++ implementation. So we can look for capture set device. Okay, audio driver. Oh, it has something to do with the audio driver. Oh, so whatever audio driver is being used for Windows is probably broken then. Set by index? No, I don't think that's how that works. Audio driver. So this must inject into. I don't really know how C++ build systems work, but it's usually based off a platform, right? So Windows must have an audio driver somewhere. Maybe. Maybe not. Like Linux almost certainly works. Platform config. Maybe it's just Windows, and then it's on... I don't know. I don't know. I don't know what I'm looking for. Where does audio driver come from? Audio driver. Audio driver. No, this is C++. We don't care about that. Audio driver manager. Audio driver. Windows audio's freaking nightmare. Linux audio is so much better. I don't know about that. All right, like tell me your opinion on ALSA versus Pulse, and get back to me. What's your opinion on ALSA versus Pulse, and then why should I be using Jack instead or Pipewire? Input. Do you use mute? Yeah, I mean the bus is muted, right? So that should be, yeah. So bus mute, everything's on the same bus. And I think in this one, this is just using the visual thing, and then this is also muted. So they're muted on both of them. Don't worry about that. If it wasn't muted, I think it would actually be playing back, so you would hear an echo. So I don't think that's it. Audio driver. So where is the audio driver coming from? OSOH. Where does this come from? Where's the constructor? The only reason people think Linux audio is difficult is because they insist on using Pulse. Well, because Pulse comes by default on... Oh yeah, Pulse is the default on Ubuntu, isn't it? So... I don't remember what Fedora uses as default. Doesn't Fedora also just use Pulse, or does it use ALSA? No. Well, no. Fedora uses Pulse and ALSA. Yeah, because I have Pulse audio running on my Fedora box. Yeah. So in my opinion, they're pretty much the same thing. Audio everywhere kind of sucks. That's pretty much it. Oh, you know what? It's late. I started late anyways, so that's fair. I usually only stream for 3 hours on Tuesdays, though. I've been very tired, though. Pulling some late nights, doing some... need to do a lot of, you know, the application at work is container native, but because it's container native, it's also impossible to run locally. So that's what I've been working on, is making it run locally so you don't need to stand up an entire Kubernetes cluster in order to just test one part. The most important part of the application. But anyways, thanks for tuning in. I'll be live tomorrow from 9 to 11 p.m. Eastern time, working on this again, probably. I'm just gonna push everything to GitHub just so you can see what the latest stuff is. Everything I work on is more or less free and open source unless it's a game, in which case I'll free and open source it once I drop it eventually. Thank you very much for the follow. The file offspring. Change buffer to use ft samples instead. Oh, forgot to commit. All right. Don't worry, I know how to use Linux. I use Linux at work. Well, actually, I use Linux and Mac at work. And I use Linux and Mac at work to access a Windows box. And from that Windows box, I get a virtual desktop, and I use that virtual desktop to access a Rails server. So it's a bit weird. Very painful. All right, let's see. Git restore assets. Very familiar with the command line though. Until tomorrow. Yeah. Thanks for tuning in. Getting ready to drop all the links in chat, but I'm not able to talk and type at the same time without accidentally typing out what I'm saying. I used to be better at it, but I don't do as many demos anymore. Because, you know, of the entire consulting thing. So you would work on a very, very niche piece of software. Gather all your own requirements, all that good stuff. Switch to using audio effect captured. He's done it. Yeah, well anyways, thanks for tuning in. I'll be live tomorrow from 9 to 11 p.m. Eastern time, working on this, probably, more than likely. Anyways, I have a Discord if you want to see that. There's a GitHub where all my code is stored under my profile. You can find the bots code there. And I don't know, yeah, that's pretty much it. Later. Goodbye.